Welcome back to the deep dive. We need to talk about the absolute state of modern infrastructure.
Oh boy.
Because honestly, I am just so tired of looking at dashboards that, they look like Christmas trees, but they tell me absolutely nothing. You
Right.
know the drill. 10 years ago, the question was simple. It was just, is the server on fire?
Yes, or
Yes or no?
and if it was, you just rebooted it.
Yeah.
Problem solved.
Those were the days. Now I've got, 50 microservices scattered across 3 regions.
Mhm.
The checkout service in US East is slow, but only for iOS users
Yeah.
and only when the recommendation engine is doing some specific batch job. It's not a needle in a haystack anymore.
Dang.
It's a needle in a stack of needles
Mm.
inside a tornado. And my cloud bill is just skyrocketing while I'm trying to find it.
That is the paradox of cloud native, isn't it?
Yeah.
We broke the monolith to get velocity, but we sort of traded simplicity for what we politely call observability.
Which just feels like drowning in data.
It often does.
Drowning is the right word. So today, we're looking at Google Cloud's latest push in this space. And I don't want the marketing fluff. I want to know if they have actually fixed this fragmentation problem.
Okay.
We're looking at their shift to open telemetry, this massive storage engine they call Monarch, and, well, inevitably, how Gemini AI fits into the mix.
It's a pretty significant stack. I mean, they're
Yeah.
basically trying to take the tools they use internally to keep things like, YouTube running and then wrap them up for the rest of us.
Let's start with the language of the data then. Open telemetry, or OTLP. I feel like for the last 5 years, every single vendor has been screaming, install our proprietary agent, use our special SDK.
Oh, the agent wars.
And if you ever wanted to switch, you had to rewrite half your code base.
It was a retention strategy, plain and simple, vendor lock-in by code instrumentation. But the industry finally just got fed up and coalesced around open telemetry.
The lingua franca.
Exactly.
Right.
The lingua franca of metrics, logs, and traces.
Okay, standards are great, but usually when a big cloud provider adopts a standard, they add their own special flavor to it that, breaks everything else. Is Google actually playing nice here?
Surprisingly, yes. And this is the first big pillar of our deep dive,
Yeah.
the Google Cloud Telemetry API. It lives at telemetry.googlelepus.com.
Okay.
The headline here is that it natively speaks OTLP.
Define natively for me. Does that mean I still need some kind of translator?
No translator. See, historically, even with open standards, you'd need a specific exporter, maybe a sidecar proxy, to convert that open standard into Google's proprietary format.
Right.
This API, it just removes that step. You can point a standard OpenTelemetry collector or even your application code directly at this endpoint, and it just accepts the data.
That sounds efficient, but I'm skeptical. Usually the generic endpoint is the slow one, or the one with lower limits. If I use the standard door, am I getting throttled compared to, say, the old proprietary CloudTrace API?
You'd think so, but the documentation actually suggests the opposite. The limits on this new telemetry API are generally more generous.
Really?
Yeah, it seems like they really want people moving this way.
Okay, but let's get into the weeds. I know you found some gotchas in the docs. There is no way a migration from a proprietary format to an open one is seamless. Where do things break?
Oh, they break. And it happens in the most annoying place possible, naming conventions. This is where the war stories begin.
I knew it. Give me scenario.
Okay, imagine you're an SRE. You've been using the old Google-managed Prometheus exporter for years.
Hmm.
You have a metric named my.uplatency. In the Prometheus world, that name is illegal. Prometheus hates dots and slashes. It only wants underscores.
So the old exporter was just silently renaming my metric.
Exactly. It would scrub the punctuation. So my.uplatency would just become my.uplatency in your database.
Mm-hmm.
And you probably wrote all your dashboards and alerts using that underscored name.
Right, of course.
Now, you switch to this new, shiny telemetry API. It supports OTLP fully, which means it allows dots and slashes. It respects the fidelity of the name.
So it ingests my dot of latency exactly as written.
As written.
I see where this is going. My dashboards are looking for the version with underscores, but the new API is sending the version with dots.
And suddenly, your graph's flatline? You think the system is down? You're waking people up at 3 a.m.
But the system is fine?
The system is fine. You just have split data. Half your history is underscored. The new data is dotted.
That is a migration nightmare. You basically have to rewrite every single query in Grafana if you make that switch.
You do. And there's another one that's even more subtle. Suffixes.
Okay.
In the Prometheus world, it's standard to append total to counters. The old managed exporter did this automatically to make non-Prometheus data feel native.
And the telemetry API.
It doesn't touch it.
So request count total just becomes request count.
Precisely.
Ah.
And if your alerting logic relies on that total suffix, well, your pager is going to go off when it should.
Okay, that's naming. What about the data itself? I saw a note about data types integers versus doubles. This feels like computer science 101, but why does it matter here?
It matters because of how the backend stores the data. See, Google's backend converts all OTLP 64-bit integers into doubles.
Into floating point numbers?
Yep.
But why? An integer is an integer.
It's all about schema collision. Let's say you have a metric that's usually an integer, like number of active users.
Okay.
But then one day, a developer updates the code and sends it as a float for some reason. If the database strictly expects an integer, it just rejects the data. By converting everything to double on ingestion, Google makes sure that the stream keeps flowing, even if the types get a little messy on the client side.
So it's a safety net.
It is, but it can be a shock if you're pulling raw data and you expect the INT64 and you get back a float. It's just another one of those little details that can break a fragile script.
One last warning on this API before we move on to data residency. I work with some clients in banking who are very, very particular about where their bits live.
Then this API is off limits for them, at least for now.
Why is that?
The telemetry API is a global service. So if you require assured workloads or impact level 4 compliance, where data must strictly stay within a specific region, you cannot use telemetry.googlelepus.com.
You have to stick to the legacy regional endpoints.
You do.
Good to know. Don't accidentally violate federal compliance just to use the new shiny API.
Exactly.
All right, so we've got the data in. We navigated the naming minefield. Now let's talk about storage. Because in my experience, the only thing harder than generating metrics is keeping them alive. Prometheus is great, but running it at scale is a full-time job.
It's the classic who monitors the monitoring system problem, isn't it?
Totally.
You start with one Prometheus server, it fills up, you add a bigger disk, that fills up, you decide to shard it, and now you're managing a fleet of Prometheus servers dealing with backups and just praying you don't lose data when a pod crashes.
And Google's answer to this is Monarch.
Yes. And this is where we need to pause, because managed service for Prometheus sounds kind of boring, but the technology underneath it, Monarch, is actually terrifyingly powerful.
Terrifyingly powerful is my favorite category of infrastructure. What is it?
So Monarch is Google's internal global in-memory time series database. It is the exact same system they use to monitor Google Search, YouTube, and Gmail.
Wait. So when I use this service, I'm not just spinning up some managed VM with Prometheus installed on it. I'm piping my data into Google's own brain.
Correct. You are renting a slice of their hyperscale infrastructure. And because it's their internal system, the rules of physics are a little bit different.
How so?
First, it's in memory. That means query speed is just blisteringly fast. You aren't waiting for a spinning disk to find your logs from last Tuesday. But the biggest game changer is retention.
Let me guess. They charge you an arm and a leg to keep data for more than, what, a month?
Actually, no. They offer 24-month retention at no additional cost for the storage itself.
2 years? I can barely keep 2 weeks of high-fidelity metrics on my self-hosted setup without blowing the budget.
That's the benefit of that shared infrastructure. You pay for the ingestion, the samples you send in, but once it's in Monarch, keeping it there is just part of the service. This fundamentally changes how you do capacity planning.
Right, because now I can actually look at you over your data. I can ask, is this Black Friday traffic spike weird compared to last year? Without having to dig up some archived snapshot from cold storage.
Exactly. It decouples the gathering from the storing. You just throw data at the API and Monarch catches it.
But I still have to get the data out of my Kubernetes clusters. Is that still a manual nightmare?
It doesn't have to be. They offer a few modes. The easy button is Managed Collection. It's an operator you just drop into your cluster GKE or otherwise, and Google handles all the scraping, the sharding, the scaling, all of it.
And if I'm a control freak who needs to run my own weird binaries?
Then you use the self-deployed mode. You run the binary, you manage the config, but it ships the data to Monarch. Or you go back to that universal language we talked about and use the OpenTelemetry collector as a Swiss Army knife to send everything.
Okay, so we've got a universal language and we've got a bottomless storage bucket. But here's the problem I deal with every single day. I work at a large enterprise. We don't have one Google Cloud project. We have hundreds.
A silo problem.
It's worse than silos. It's walled gardens. If I'm debugging a transaction that starts in the mobile app project, hits the API gateway project, goes to the auth project,